Let us solve a question on fixed proportion production function. The question is, consider the following production function f of x1 comma x2 is equal to minimum of bracket 3x1 comma x2. The price of input 1 is w1 and of input 2 is w2. Determine the optimal amount of each input and minimum total cost when the firm wants to produce 21 units of output. Okay, so we have this production function. Q is a function of two inputs, that is x1 and x2, and they are related with each other by this relationship, that is minimum of 3x1 comma x2. This is actually our leontief production function, what we also call the fixed proportion production function. uh, it simply means if we want to produce a certain level of output, we are supposed to use the inputs in a fixed proportion. Okay, we cannot disturb the proportionality of the inputs. Okay, now given this production function, and we are also being told to find out the minimum total cost, that means this is a cost minimization problem. Okay, so our question will look like this. So we will want to minimize the cost. And what is the cost? That is simply the price of input 1 times units of input 1 plus the price of input 2, which is w2 here being given, times units of input 2. This is, we want to minimize this cost subject to the production constant. What is the production for constant? That is minimum of 3x1 comma x2 should be equal to q. Okay, we want to minimize this cost function subject to this production isocount. Okay, now production will occur, and let me write it here. Production will occur at a point where, or let me write it here, uh, optimal input mix in case of Leontief production function requires that uh, we equate the total output that is supposed to be produced with the terms that are in the parenthesis, that is 3x1, and we equate it with x2. Okay, and when we solve these for x1 and x2, so if q is equal to 3x1, it implies x1 will be equal to q upon 3. Similarly, x2 will be equal to q. Okay, these are our input demand functions. Okay, what we call the conditional input factor demand here, rather conditional input demands here. Conditional in the sense that it depends upon the output that we are supposed to produce. These are not the unconditional input demands here. Okay, so basically if I want to graph this out like this, so if we have units of x1 on the horizontal axis, units of x2 on the vertical axis, okay, we will get L-shaped isocount here, and I will explain that very stuff also. Now we are being told, so we have found out the optimal amount of each input. Okay, but if we want it in numbers, so we should fix q is equal to 21. So here in place of q we have 21, since we want to produce 21 units of input. So here when we solve for q is equal to 21, that means we require 21 upon 3, that comes out to be 7 units of input 1, and x2 is equal to q and q is equal to 21. That means we need 21 units of input 2 to produce 21 units of output. Okay, now let's explain this with the help of the graph. It will make more sense. Let us say we have input 1, that's x1 on the horizontal axis, and input 2, which is x2 on the vertical axis. Since we have solved for x1 and x2, we got to produce 21 units of output, we require 7 units of input 1 and 21 units of input 2. Let us suppose this is 7, this is here is 21. So let us suppose it is the point. So let's draw the isocount for q is equal to 21. So remember, in case of fixed proportion production function, what we call the Leontief production function, our isocount will be L-shaped. Okay, so to verify that this actually is our optimal input mix, we can substitute these values here in our production function. So since x1 is equal to 7, x2 is equal to 21, let us plug these values into the production function. That is q will be equal to the minimum of 3x1, so 3x1 comma x2, so our q will be equal to, so 3x1 is 7 comma x2 is 21, so q will be equal to, so here we have minimum, this is also minimum, sorry, so minimum of 21 comma 21 comes out to be 21. Okay, that means we require 7 units of input 1 and 21 units of input 2 to produce 21 units of 21 units of output. Let us suppose we unilaterally increase units of x1 to, let us say, 10. Okay, and let me write it. Suppose x1 is equal to 10 and we fix x2 at 21. What will happen? What will happen if we have these very combinations other than the optimal here? So plugging them into the production function, that is q will be equal to minimum of 3x1 comma x2, so we have minimum of 3x1 is 10 comma x2 is 21, and here you can see our production function will be, sorry, our production will be 3 tens are 30 comma 21, and minimum of these two numbers is again 21, so 21, we still are able to produce only 21 units of output when we increased the units of x1 unilaterally to 10 units without changing x2 in the same proportion. Okay, so here you can see our optimal production will take place at that very point. Okay, where we have the kink in this isocount. So if we want to increase q is equal to, we have 21, if we want to produce q is equal to 22, okay, then what we need to do, we need to increase both the inputs in the same proportion. Okay, so if we increase any input without changing the other input in the same proportion, our production will not increase, only the cost will increase here. Okay, now also we are being told to find out the total cost. Now what will be the total cost? That is simply equal to, simply plug x1 and x2 into the cost function. So w1, we have w1 into x1, w1 into 7 plus w2 into 21. That means our total cost function will be equal to 7w1 plus 21w2. Okay, this will be our cost function. I hope I make myself clear in this video. Thank you.